Okay, this is a really short little mini lecture on thinking about how much temperature an object changes when we give it heat, when it has some heat transferred to it. And what might that be dependent on? If I transfer a certain amount of energy to, let's say, aluminum, does that look different in terms of how the temperature of that aluminum changes if I transfer that same amount of energy to water? Would those look the same or would they look different? Well, chances are they're going to look different. They're different materials. And so in this mini lecture, we're going to introduce what all of that is dependent on, and that is a process and an idea known as specific heat. So the first thing that is going to be influencing how much temperature change a material gets is what's known as the specific heat of the material. And that's a empirical result. It means it's a discovered result for each material. It's not like a universal constant that is a constant in proportionality, like we've talked about other things, but this is actually an empirical result for each material. And it is a property of that material. And we use the lowercase letter c for an object-specific heat. Okay? And again, that's dependent on the material. And the value of the specific heat is at standard temperature and pressure. And that is defined, as we've mentioned before, 1 atmosphere at 20 degrees Celsius. Okay, so our standard temperature and pressure is 1 atmosphere at 20 degrees Celsius. Now, how much temperature an object changes by, how much heat is transferred, is also dependent on the mass of that object. More mass, you might expect that temperature change to not be as much, right, if I give it a certain amount of energy. And if the initial temperature that it's at is also going to play a role. So the change in temperature is what's most important, okay? And we find that the relationship between all of these things is that the heat, Q is our heat, is equal to the mass times the specific heat times the change in temperature. And this governs how much energy is required, how much energy, heat, to change a certain object of a given mass by a specific amount of temperature, okay? All right, so let's just do an example to use that. Let's imagine, let me pull the example up. We want to know how much heat is required to, that should say raise. Let's just fix that while I'm here. Forgot an E. An empty vat of aluminum, so imagine like a pot, a vat of aluminum, and that aluminum weighs 10 kilograms from 10 degrees Celsius to 90 degrees Celsius. And then what if it was filled with water? That vat was filled with water. How would that change how we look at how much heat is needed? Okay, so we need to know a couple of things. We need to know the specific heat of aluminum for part A, and we need to know the specific heat of water for part B. And unless it's stated, we're assuming standard pressure and temperature. And so the specific heat of, we're going to look at that specific heat value. The specific heat of aluminum is equal to 900 joules per kilogram times degrees Celsius is the unit. And the specific heat for water is 4186 joules per kilogram degrees Celsius. So that number should sound familiar. That was that number we've used before. All right, so let's just use this relationship, this equation, to look at part A. So part A is asking how much heat is required for 10 kilograms of aluminum going from 10 degrees to 90 degrees. So Q is equal to the mass. We're told that we have 10 kilograms times the specific heat of aluminum, which is 900, times our change in temperature. So our final temperature minus our initial temperature. So that is 90 degrees minus 10 degrees. And we find that the heat required is 7.2 times 10 to the 5th joules. So that is part A. So just using that relationship. Okay, part B asks, what if that vat was filled with water? So if I want to raise this system now, I need to know what the heat is required to raise the vat and the heat required to raise the water. So for part B, the total heat is going to be the heat for the aluminum plus the heat for the water. Okay? And we already know the heat for the aluminum, so that one we're set with. Let's find the heat for water. Oh, I'm not going to have enough room if I put it over there. I'll just do it down here. So Q for water is going to be, well, I have, what does it say? 5 kilograms of water, so my mass is 5. The specific heat of water is 4186 times, and I'm still going that 90 minus 10 or 80 degrees of temperature change. And when we do that, we find our amount to water is, excuse me, 1.7 times 10 to the 6th joules is the amount of heat required to move this 5 kilograms of water by 80 degrees. And so I can plug that in for this value, and we find our total heat to be 7.2 times 10 to the 5th plus 1.7 times 10 to the 6th, and we get 8.9, no we don't. We get 2.4 times 10 to the 6th joules. All right, so just using that relationship for specific heat to look at how much energy is necessary to raise different materials by a certain amount in temperature. All right, good job.